We have a small electric motor that's down low by the battery pack.
We are 70% water and only 30% land. And so really, the availability of fresh water is simply about energy and transport.
But I think he's legit. Like, everything I've looked at, it's like this guy actually made this thing which could totally revolutionize the world.
In a shocking announcement, Elon Musk has taken to X to reveal a major shift in Tesla's future. The company, long known for pioneering battery-powered electric vehicles, is now turning its focus toward hydrogen fuel cells. This bold move comes as Tesla struggles to mass-produce its highly anticipated 4680 battery cells, pushing the company to explore alternative, sustainable energy solutions. But that's not all. Musk has also introduced Tesla's revolutionary water engine, a breakthrough technology expected to play a key role in this transition. So, what makes this water engine so groundbreaking? How will it transform not only the automotive industry, but also other sectors? Stay tuned, because what you're about to hear will completely change the way you think about sustainable energy. Elon Musk has always been obsessed with pushing the boundaries of technology and sustainability. As the visionary behind Tesla and SpaceX, he has relentlessly pursued innovations that have reshaped entire industries. But Musk's vision for Tesla was never just about building electric cars, it was about revolutionizing transportation itself. By proving that electric vehicles could outperform traditional gasoline-powered cars, he accelerated the world's shift towards sustainable energy, and his ambitions don't stop on Earth. With SpaceX, Musk has set his sights on making space travel accessible to the masses and paving the way for human colonization of Mars. His determination to turn ambitious dreams into reality has solidified his reputation as one of the greatest technology pioneers of our time. Now, let's talk about this so-called water engine. It's not just a concept, it's a practical, game-changing technology, and the reasons behind its potential will absolutely blow your mind. If there's one thing we've learned from Musk's track record, it's that he doesn't just dream, he delivers. Just look at what SpaceX has accomplished. When the idea of reusable rockets was first introduced, most people thought it was impossible. But today, thanks to SpaceX's engineering expertise, rockets can land and be reused, dramatically cutting the cost of space travel. And the same story applies to Tesla. When the company launched in 2003, the world doubted that electric vehicles could ever compete with gas-powered cars. Back then, EVs were seen as impractical, with limited range and poor performance. But Musk proved the skeptics wrong with the Tesla Roadster, a high-performance electric car that shattered expectations and proved that electric mobility was the future. From there, Tesla kept pushing forward, introducing models S, X, 3, and Y, each one setting new standards in battery technology, range, and self-driving capabilities. Today, electric vehicles are not just a viable option, but an increasingly desirable one for millions of consumers. But Musk's interest in sustainability goes far beyond cars. With the Tesla Powerwall and solar roof, he has worked to create an entire sustainable energy ecosystem. These innovations allow homes and businesses to generate and store solar power efficiently, reducing dependence on fossil fuels and making clean energy more accessible. And let's not forget about space exploration. SpaceX's Falcon 9 rocket has completely changed the game, drastically reducing the waste associated with rocket production. Meanwhile, the Starlink satellite constellation is on a mission to provide global internet coverage, connecting even the most remote corners of the world. Now, back to the water engine. This revolutionary technology operates on a simple yet ingenious principle, using water to generate energy. And here's where things get really interesting. Traditional combustion engines burn fossil fuels, while electric vehicles rely on lithium-ion batteries. But neither of these solutions can fully meet the world's growing demand for clean energy. That's where the water engine comes in. It harnesses a process called reverse electrolysis. Here's how it works. Ordinary electrolysis uses electricity to split water into hydrogen and oxygen. Reverse electrolysis does the opposite. It combines hydrogen and oxygen to generate electricity, with water vapor as the only byproduct. No harmful emissions, no burning of fossil fuels, just clean, sustainable energy. Here's how it works. Water is added to the system, and a small initial energy input splits it into hydrogen and oxygen. These gases are then stored in separate tanks inside the vehicle. When the engine runs, hydrogen flows into a fuel cell where the magic happens. Inside the cell, hydrogen is split into protons and electrons. The electrons generate an electric current that powers the motor, while the protons combine with oxygen to form water vapor. This process creates a continuous loop. Water turns into energy, then back into water again. It's a game changer in the pursuit of sustainable, environmentally friendly energy. Inside the fuel cell, protons pass through a special membrane and combine with oxygen from the air to produce water vapor. As long as hydrogen and oxygen are supplied, the process continues generating electricity with impressive efficiency. But how does this water-powered engine stack up against traditional gas engines and even electric vehicles? The results might surprise you. When comparing different engine types, the numbers speak for themselves. Traditional combustion engines are notoriously inefficient, converting only about 20–30% of their fuel into actual usable energy, with the rest lost as heat. Electric engines, on the other hand, perform significantly better, boasting an efficiency of 85–90%. However, they come with their own drawbacks: slow charging times, battery degradation over time, and environmental concerns surrounding battery production. The water engine falls somewhere in the middle, with an efficiency of around 60%. While it doesn't quite match electric vehicles in raw efficiency, it makes up for it in other ways. Unlike battery-powered EVs, which require long charging times, water engines can be refueled just as quickly as a gas-powered car. This means no more waiting hours for a recharge. Just fill up and go. Another major advantage? Zero emissions. While gas engines pump out harmful carbon dioxide and pollutants that contribute to climate change, the only byproduct of a water engine is water vapor. If widely adopted, this could make a huge difference in cutting down carbon emissions and improving air quality, especially in urban areas. To put things into perspective, the average gas-powered car emits about 4.6 metric tons of carbon dioxide per year. Imagine if every car on the road produced nothing but water vapor instead. Environmental activists argue that switching to water engines could dramatically reduce air pollution, eliminating harmful nitrogen oxides and particulate matter that contribute to respiratory diseases. Even electric cars, though cleaner than gas vehicles, are not entirely without flaws. Mining for materials like lithium and cobalt, used in EV batteries, has a significant environmental impact, and if the electricity used to charge EVs comes from fossil fuels, the carbon savings aren't as substantial as they might seem. Hydrogen. Fuel cells have been explored as an alternative, but they come with their own challenges. Producing hydrogen often relies on natural gas, which still releases carbon emissions. Storing and transporting hydrogen also presents difficulties. It has a low energy density and requires high-pressure tanks to remain stable. This is where Tesla's engineers believe they have found the ultimate solution. By using reverse electrolysis, their water engine could overcome these challenges in a cleaner, more efficient way. And beyond just environmental benefits, the water engine could also be a game-changer financially. Gas-powered cars require frequent maintenance, oil changes, exhaust repairs, and other upkeep that add up over time. Electric cars have fewer moving parts, which helps reduce maintenance costs, but battery replacements can be expensive and environmentally damaging. With its simpler design and fewer components, the water engine promises lower maintenance costs and a longer lifespan for vehicles. And as the technology advances and mass production ramps up, the initial cost of water-powered cars could drop, making them an affordable alternative to both traditional gas and electric vehicles. Challenges and opportunities come hand in hand when it comes to adopting water engines. One of the biggest hurdles Tesla faces is the enormous upfront investment required to build a widespread refueling network. Unlike traditional gas stations or the expanding EV charging infrastructure, water refueling technology is virtually non-existent. For this transition to be successful, governments and private companies must collaborate on a global scale to create an efficient and accessible network. However, this shift presents significant opportunities as well. A widespread transition to water engines could reduce global dependence on oil, leading to more stable fuel prices and easing geopolitical tensions tied to oil supply chains. Additionally, the move towards sustainable energy could have far-reaching economic benefits, creating new industries focused on water engine technology, manufacturing, and infrastructure development. This could result in a surge of job opportunities and further advancements in clean energy solutions. That being said, Tesla must also overcome resistance from entrenched industries that rely on fossil fuels. The automotive world has been built around traditional internal combustion engines, and even the shift to electric vehicles has faced challenges from industry giants reluctant to abandon legacy systems. Many stakeholders, from fuel suppliers to vehicle manufacturers, may find Tesla's push toward water engines disruptive, leading to potential opposition. To navigate these challenges, Tesla could leverage existing technologies, particularly those from hydrogen fuel cell research, to accelerate development and deployment. Since water engines share similarities with hydrogen-based systems in terms of design and storage, integrating existing knowledge could fast-track their viability. The big question remains, will Musk's water engine redefine energy and transportation, or will it struggle against these mounting obstacles? The automotive industry is watching closely, as Tesla's announcement has the potential to spark a major shift in how we think about sustainable mobility. For this technology to succeed, Tesla must refine its reverse electrolysis system to be both efficient and cost-effective, establish a reliable refueling infrastructure, and ensure safety and reliability. Meanwhile, major automakers like Toyota and Hyundai, who have long championed hydrogen fuel cell technology, have responded to Musk's announcement with mixed reactions. Toyota, for instance, sees Tesla's move as a validation of its long-held belief in hydrogen's potential and welcomes the increased interest in alternative fuel sources. Having already invested heavily in hydrogen engine research, Toyota views this as a step toward wider acceptance of hydrogen infrastructure. Hyundai, on the other hand, has been more reserved, with reports suggesting the company remains hesitant about committing to large-scale hydrogen or water engine development due to high costs and uncertain demand. Skepticism isn't limited to automakers. Industry experts remain divided. While some hail Musk's move as groundbreaking, others question its practicality. Joseph Raw, a former U.S. Department of Energy official, has been vocal about his doubts, stating that hydrogen-powered vehicles are among the least efficient and most expensive solutions for reducing greenhouse gas emissions. He also pointed out that building a nationwide network of hydrogen refueling stations would be prohibitively expensive. These concerns were echoed by a group of over 100 scientists led by Professor David Gibbon of the University of Cambridge, who criticized hydrogen-powered vehicles ahead of the Paris 2024 Olympics. They argued that hydrogen engines require nearly 3 times the renewable electricity of battery electric vehicles, making them far less efficient. Furthermore, the fact that most hydrogen is still produced from fossil fuels undercuts its green reputation. Despite these concerns, Tesla's approach to water-powered engines may address some of these issues. Whether it can overcome the skepticism and logistical challenges remains to be seen. Ultimately, the success of this technology will depend on public perception and adoption. Musk's announcement has sparked widespread discussion across social media, with Tesla fans and environmental advocates expressing enthusiasm about the potential of water-powered vehicles. Many are excited by the prospect of a cleaner, more efficient transportation system that eliminates harmful emissions. However, some remain skeptical, especially given Musk's previous dismissal of hydrogen technology. For years, he criticized hydrogen fuel cells as inefficient and impractical. Now, with this sudden shift in Tesla's strategy, people are questioning his motivations and whether this technology can truly deliver on its promises. Beyond public skepticism, one of the biggest concerns is the challenge of creating an entirely new refueling infrastructure. While gas stations are abundant and EV charging networks are expanding rapidly, building a comparable system for water engines would require significant investment and international cooperation for the water engine. To become a reality, several key challenges must be addressed. First, reverse electrolysis technology must be optimized for greater efficiency and lower costs. Second, a user-friendly and widely available refueling infrastructure must be developed. Lastly, Tesla will need to convince the public that water engines are not just viable, but also safe, affordable, and practical. The road ahead is uncertain, but one thing is clear. If Tesla can overcome these hurdles, it could once again revolutionize the transportation industry and lead the way to a cleaner, more sustainable future. If Musk and his team can overcome these obstacles, the water engine could revolutionize transportation and pave the way for a greener future. However, the journey is filled with uncertainties, and only time will tell if this bold vision becomes reality. Unlike the well-established network of gas stations and the rapidly growing EV charging infrastructure, hydrogen refueling stations remain scarce. They are concentrated mainly in California, Japan, and parts of Europe. While this existing network offers a foundation for water engines, since they utilize a similar hydrogen-based refueling process, significant expansion is required to support widespread adoption. Tesla has a plan to address this challenge. According to company sources, Tesla intends to leverage its expertise in building EV supercharging stations. The company plans to retrofit existing EV stations with hydrogen refueling capabilities while also constructing new stations specifically designed for water engines. This ambitious endeavor will demand substantial investments and collaboration with governments and private sector partners to ensure widespread accessibility and consumer convenience. Despite this strategy, key questions remain about how quickly this infrastructure can be developed and the logistical and financial challenges that must be overcome. The cost of infrastructure development, the reliability of hydrogen production and distribution, regulatory compliance, and public perception are all critical hurdles Tesla must address to successfully integrate this new technology into the market. Safety is one of the most crucial aspects of any new technology, and the water engine is no exception. Hydrogen is highly flammable and requires careful handling, and since the water engine converts water into hydrogen, it inherits these safety concerns. Tesla has taken steps to mitigate risks by designing an advanced hydrogen storage system, ensuring that hydrogen is stored securely within the vehicle. These storage systems are built to withstand high pressure and prevent leaks, undergoing rigorous testing to meet and exceed international safety standards. Despite these precautions, public perception remains a challenge. To build trust and confidence, Tesla will need to maintain transparency and communication regarding the safety measures of the water engine. Additional steps, such as public awareness campaigns and independent safety certifications, could help reassure consumers that this technology is both viable and secure. Beyond safety, regulatory and legal challenges present another major obstacle. Hydrogen storage, transportation, and usage regulations vary across different countries, and Tesla will need to work closely with regulatory bodies to ensure compliance. The approval process is complex, requiring extensive documentation, rigorous testing, and ongoing collaboration with regulators to address safety concerns and adapt to evolving industry standards. Without meeting these regulatory requirements, Tesla will face significant barriers to global adoption. This raises an important question. Is all this effort worth it? To answer that, it's essential to compare water engines to other emerging clean technologies, particularly hydrogen fuel cells. Hydrogen fuel cells offer high energy density, allowing for long driving ranges and quick refueling. They emit only water vapor, making them an environmentally friendly alternative. However, they come with challenges, particularly in producing, storing, and transporting hydrogen gas, which is costly and requires specialized infrastructure. Water engines, on the other hand, offer an advantage in on-demand hydrogen production, reducing the need for large-scale hydrogen storage and minimizing risks associated with handling pressurized hydrogen gas. Additionally, water engines can integrate seamlessly with renewable energy sources, further enhancing sustainability. However, reverse electrolysis, the core process behind water engines, requires a significant initial energy input, which can impact overall efficiency. Ultimately, the success of the water engine will depend on several factors, including its ability to overcome technical barriers, establish a robust refueling infrastructure, and compete with existing technologies such as battery electric vehicles and hydrogen fuel cells. While the cost of research, development, and investment remains high, the market potential for water-powered vehicles is promising. The automotive industry is already shifting towards sustainability, with governments around the world setting stricter emissions targets and offering incentives for clean energy technologies. This creates a favorable environment for innovations like the water engine. In the early stages, water engines may appeal primarily to early adopters and environmentally conscious consumers. However, as technology improves and costs decrease, mass adoption could become a reality. According to market analysts, if Tesla successfully resolves challenges related to efficiency, infrastructure, and scaling, water engines could gain significant market share in the coming decade. Strategic partnerships with both public and commercial sectors could further accelerate growth and adoption. However, the water engine will not be alone in the market. It will have to compete with well-established technologies like BEVs and hydrogen fuel cells, each with its strengths and weaknesses. Factors such as cost, driving range, refueling time, and environmental impact will play a significant role in shaping consumer preferences. Elon Musk's determination and Tesla's engineering expertise will be critical in shaping the future of this technology. But will the water engine prove to be the revolutionary breakthrough Musk envisions, or will it face insurmountable obstacles? Only time will tell. Now, let's consider some of the obstacles that stand in the way of the widespread adoption of water engines. Musk's plans are ambitious, but not without hurdles. One of the biggest challenges lies in overcoming the technology gap between current fuel solutions and water-powered systems. While electric vehicles have the advantage of a gradually improving infrastructure, water engines are still in their infancy. For water engines to compete with electric and hydrogen-powered vehicles, there will need to be a massive shift in how energy is produced, stored, and used. Hydrogen, while promising, still faces a range of issues. The infrastructure for hydrogen production, storage, and refueling is limited at best. If Musk's water engine is to become viable on a large scale, it will require a network of facilities capable of producing, storing, and distributing hydrogen more efficiently and cost-effectively. Additionally, the cost of electrolysis equipment, which splits water into hydrogen and oxygen, must drop significantly to make the technology commercially feasible. With the right strategic moves, however, these barriers could be overcome. But the question remains, how soon will all this happen? While Musk has a track record of shaking up industries and defying expectations, the road to revolutionizing the automotive sector with water engines will not be an easy one. The next few years will determine whether these engines are just another ambitious dream, or if they will transform the transportation landscape. However, there's another side to this equation. The market for water engines isn't just about competing with other alternative fuels. It's about reshaping the way we think about energy itself. Imagine a world where energy is abundant and vehicles run on water that can be easily and sustainably sourced. This could change everything, from the way we power our homes to how we transport goods across the globe. In the end, whether or not water engines succeed hinges not only on technological innovation, but also on public perception and government support. If governments worldwide invest in the infrastructure needed to support water engines, along with favorable policies and regulations, the transition to a cleaner, more sustainable future could happen faster than we think. In closing, the water engine revolution isn't just a possibility. It's something we might very well see in our lifetimes. While the path forward is challenging, the potential rewards are massive, from reduced emissions to a more sustainable world for generations to come. It's clear that Elon Musk and his vision for water-powered cars aren't just a fleeting dream, but a long-term commitment to reshaping the future of transportation. The only question is, are we ready to embrace it? So, what would the world look like if water engines became the norm? Imagine a future where fueling up doesn't involve driving to a gas station. Instead, you simply refill your vehicle with water, which could be as simple as filling up a tank or connecting to a local water supply. Think about how much cleaner our streets would be, how much less pollution would spew into the air, and the drastic reduction in our reliance on oil. Not only that, but water-powered engines could make transportation vastly more affordable in the long run. The cost of fuel could be dramatically reduced since water is plentiful and inexpensive compared to the ever-fluctuating costs of oil. With that, the global economy could see a major shift. Energy independence would no longer be a distant dream, but a reality. Countries wouldn't be at the mercy of fossil fuel markets, and the strain on natural resources could lessen over time. However, the timeline for this shift is still unclear. Could we be seeing water-powered cars within the next decade, or is it more of a long-term goal for future generations? The truth is, it could be sooner than we think. We've already witnessed the rapid development of electric vehicles and autonomous driving technology in recent years. What was once considered a far-fetched idea is now becoming a part of daily life. Water engines, though, face even more unique challenges. For one, we would need to see breakthroughs in water electrolysis efficiency. The process of splitting water into hydrogen and oxygen molecules isn't perfect, and there's still a long way to go in terms of refining it to make it both energy efficient and cost-effective. But again, let's look at history. Just as the electric car faced skepticism and technological hurdles, it has now become an increasingly common sight on the road. Another hurdle will be the public's acceptance of the technology. People are often resistant to change, especially when it involves their everyday lives. Transitioning from gasoline to electricity wasn't easy, and it won't be with water engines either. Consumers need assurance that these engines are safe, efficient, and practical. This means real-world testing and early adoption, likely driven by a handful of high-profile successful projects, before it can spread more widely. We also can't ignore the fact that automakers and their profits will play a role in the adoption of water engines. The transition to water-powered vehicles could disrupt existing industries. Traditional internal combustion engine manufacturers and oil companies may fight to hold on to their market share, even if it means delaying progress. Government intervention and incentive programs could help push water engines forward, but their success ultimately depends on the collaboration of private and public sectors. As we think about this, it's important to also consider the environmental implications of large-scale water engine use. While water itself is renewable, the process of producing the fuel could still have environmental costs, particularly if the energy used for electrolysis comes from non-renewable sources. Musk's goal of optimizing the reverse electrolysis process would be crucial in ensuring that the energy used to split water into hydrogen and oxygen is as clean as possible, possibly making use of renewable energy sources like solar or wind. This, in turn, could contribute to a truly sustainable solution for the future of mobility. Ultimately, while we may not have all the answers today, the potential for water engines is undeniable. The technology is still in its early stages, but with visionaries like Musk leading the charge, anything is possible. Just like the electric vehicle revolution, the future could surprise us in ways we can't yet imagine. In the meantime, it's important to keep an eye on developments in this space. Research, partnerships, and breakthroughs could accelerate the transition to water-powered transportation sooner than we think. If Musk and his team can overcome the hurdles that stand in their way, we could soon find ourselves driving cars fueled by nothing more than water. And that, my friends, would be the next great step in human innovation. Now, let's take a look at where we go from here. What does the future hold for water engine technology, and who will be the major players aside from Tesla? The most exciting part of the video is coming up. You won't want to miss it. While Tesla's water engine shows great potential, other companies and innovations could also rise as contenders in the sustainable transportation race. Take Nikola Corporation, for example. Specializing in hydrogen-powered trucks, Nikola represents a formidable rival. Despite some setbacks, the company has made significant progress in developing heavy-duty vehicles with hydrogen fuel cells. They're focused on the commercial market, which could pose a serious challenge to Tesla, especially in the long-haul trucking sector. BMW is also in the game, applying its strong reputation and engineering expertise to water engine technology. The company has been researching hydrogen fuel cells, revealing prototypes, and committing to further development. BMW's entry into this space could intensify competition, especially in the luxury vehicle market. Another key player could be Rivian. While primarily known for its electric vehicles and backed by major investors like Amazon and Ford, Rivian's innovative approach and substantial funding could allow it to pivot towards water engine technology if demand shifts in that direction. Collaborations will be crucial for the rapid development and widespread adoption of water engines. Tesla, known for forming strategic partnerships, could work with other automotive companies, energy providers, and research institutions to accelerate innovation, build infrastructure, and reduce costs, ultimately benefiting the entire industry. And consumers, the competition in the water engine market will be fierce. Tesla's success will rely on its ability to stay ahead of the curve, pushing the boundaries of technology, forming strategic alliances, and adapting to evolving market needs. Tesla could partner with leading tech companies, universities, and research institutions to access cutting-edge research, specialized knowledge, and advanced technologies. Collaborating with universities at the forefront of hydrogen research could improve the efficiency and performance of Tesla's water engine. For instance, partnerships with material science departments might yield more durable electrolysis systems, while working with experts in hydrogen storage could result in safer and more compact storage solutions. On top of that, tech giants like Google or Apple could help integrate advanced software and AI into water engine vehicles. To achieve true environmental sustainability, hydrogen for these engines could be produced through electrolysis, powered by renewable energy sources like solar or wind. Imagine homes with solar panels generating hydrogen fuel during the day, which could then power water engine vehicles. However, the potential of water engines extends far beyond cars. Tesla, according to insiders, is exploring their use in aviation. Ships powered by water engines could drastically reduce the environmental impact of global shipping, contributing to cleaner oceans and air. This is particularly important given the shipping industry's large contribution to global greenhouse gas emissions. Water engines could also provide sustainable alternatives in energy-hungry industries like manufacturing, mining, and construction, helping them transition toward cleaner energy sources. Water engines could revolutionize not only transportation, but also power generation and industrial processes, paving the way for a greener, more sustainable future. Thank you for sticking with us. Do you think water engines will define the future of clean energy transportation? Share your thoughts in the comments below. If you enjoyed the video, don't forget to like, share, and subscribe to our channel. Also, be sure to check out the next video on your screen. We're confident you'll love it. You'll love